Hey, everybody. This is from day 1-9 and question 11 in your practice. So we'll go through and we'll deal with a relatively quick solution. You take a peek at the problem on the screen. Can you use factor theorem to prove that that cubic is divisible by x squared minus x minus 2? Okay, what's really important in this problem is use factor theorem. You are not using factor theorem to prove that that cubic is divisible by that quadratic if you do long division. You're not. So we got to make sure that we're using factor theorem. So if we have to use factor theorem, we need to know what factor theorem means. So just recall that what it says is that if my function, and I'm going to just sneak in a little f of x so I can talk about it with function notation, that if I was to sub something into my function, and I will just call that happy face, and it gives me 0, then x minus whatever I subbed in is a factor. So that's all factor theorem means. Remainder theorem tells us that whatever we sub in, we would always get the remainder as if we had divided by x minus that. Factor theorem nails it down to zeros. Because a factor would divide evenly, it would give you a remainder of 0. That's what we're looking for. So how do you now go through that process to show that it's divisible by this? Because remember, therefore, x minus that is a factor. Notice, that's linear. Remember, factor theorem works with linear divisors. Our problem is what I underlined in red was quadratic. So if you hit a bit of a wall on that one, I think we should be able to see it's actually pretty quick. If I was to take my divisor, my x squared minus x minus 2, and I want that to be linear, then what I can do is I obviously can't change the degree, but if I factored it to see what makes that up, now I have two linear factors, I can use factor theorem. So when you take a peek at that x minus 2 and x plus 1, if you were able to prove using factor theorem that both of those factors are factors of f of x, then you've done your job. You've proven that the quadratic is. If there's any part of that theory that's kind of jamming you a little bit, imagine it this way. If I asked you to show that 6 was a factor of some number, my cubic, my original function, then you could divide by 6 and get 0, or show, using factor theorem, your version of that algebra. But instead, what you could do is if you showed that 3 was a factor and 2 is a factor, then you have proven that 6 is. And that's all we're doing here. If you can prove that x minus 2 is a factor and x plus 1 is a factor, then its product, x squared minus x minus 2, must be a factor. So in terms of solution for us, I don't know if you really even need this, and I'm not really going to go through in detail for it. But for you, you are sufficient in your solution to then show that f of 2 equals 0 and f of negative 1 equals 0. If you can do the purple, you've then proven that for that, or solved that problem. Okay, I'm hoping that that's helping you through your practice. Good luck with the rest.